So hello, a very good afternoon to all. My voice is audible to all of you. Please confirm me once. सबको मेरी आवाज आ रही है ना? चलो, ठीक है. So today basically what we are going to do that we are going to solve some PYQ question related to this chapter alcohol, phenol and ether, right? So in the last class we are discussing or revising the main concept of this chapter alcohol, phenol and ether. Today also we are going to discuss some important things, but the main focus on today's class is solving questions, right? That which type of question generally coming from this chapter alcohol, phenol and ether, right? So I hope my screen is also visible to all of you. Yes, yeah, got it. So let's start with the today's session, right? So before starting the question practice session, let me quickly describe the mechanism of the dehydration of alcohol, because the I observed that some questions are also coming from this topic, that is dehydration of alcohol. So before going to the question part, let me explain the mechanism of the dehydration of alcohol, right? And which primary, secondary, tertiary, out of this, which alcohol is more reactive toward the dehydration, right? Okay, so first of all, what is mechanism of the dehydration of alcohol? Okay, let me record the session. Okay, so the reaction occur in the three steps basically. The first step is protonation of oxygen of the OH group, right? Then first step, protonation will be takes place. Protonation means what? Protonation means what? Can anyone define what is protonation? Protonation means when the H loses its electron and become H plus, right? This is called protonation. Now, in the second step, loss of water to give a carbocation, and the third step, loss of proton from the neighboring carbon atom, which produces an alkene. So this is all about the mechanism of the dehydration of alcohol. Let's see with an example, right? So here we have an alcohol. This is a cyclohexanol. We all know this is cyclohexanol, right? So this is cyclohexanol. We all know. What happened in the first step, protonation will be takes place. How protonation will be takes place, beta? Because we all know that O in OH, O having lone pair of electron, right? O having lone pair of electron. So due to presence of this lone pair of electron, right? This protonation will be takes place. So this H plus, so this H, where from this H plus came? कहाँ से आएगा ये H plus? Yes, so dehydration of alcohol takes place in the presence of some acid, right? Some acid, like H2SO4. So H2SO4 provide H plus. So this H plus, ये H plus क्या होगा? जल्दी से इस O पे कंबाइन हो जाएगा, because O के पास लोन पेयर ऑफ इलेक्ट्रॉन है, तो वो इसको एक्सेप्ट कर लेगा, राइट? तो ये H plus हो गया. नाउ अब ऑक्सीजन पे पॉजिटिव चार्ज हो गया, विच इज नॉट गुड थिंग, राइट? बिकॉज ऑक्सीजन इज इलेक्ट्रोनेगेटिव एंड दे डू नॉट वांट कि उस पे कभी भी पॉजिटिव चार्ज आए. तो वो क्या करेगा? अब वो कार्बन से इलेक्ट्रॉन लेने की कोशिश करेगा, राइट? बिकॉज ऑक्सीजन इज मोर इलेक्ट्रोनेगेटिव देन कार्बन एंड दे डू नॉट वांट कि उसके ऊपर कभी भी पॉजिटिव चार्ज आए. दे फील अनस्टेबल. तो वो क्या करेगा? इस कार्बन बॉन्ड से इलेक्ट्रॉन लेने की कोशिश करेगा. एज अ रिजल्ट ऑफ दिस कार्बोकैटायन विल बी फॉर्म. इससे रिजल्ट क्या होगा बेटा? कार्बोकैटायन फॉर्म हो गया. तो प्रोटोनेशन ऑफ अल्कोहल से क्या बन गया? कार्बोकैटायन. नाउ अब ये कार्बन क्या करेगा? कार्बन पे कार्बोकैटायन आ गया. तो हम लोगों ने पढ़ा है ये सब चीजें जब 11th क्लास पढ़ रहे थे. दैट इज हाइपर कॉन्जुगेशन, इंडक्टिव, रेजोमेरिक, मेसोमेरिक डिफेक्ट, रेजोनेंस डिफेक्ट, ये सब हम लोगों ने इफेक्ट को पढ़ा है, राइट? सो ये क्या करेगा? इस वाले H से यहाँ पे इलेक्ट्रॉन को लेगा और अपने कार्बोकैटायन को दूर करेगा. एज अ रिजल्ट यहाँ पे क्या आ गया? डबल बॉन्ड का फॉर्मेशन हो गया. सो दिस इज हाउ एल्कीन फॉर्म्ड from alcohol. So this is the mechanism of dehydration of alcohol to give corresponding alkene, right? And the three step involved in this reaction is protonation of oxygen of the OH group, loss of water to give a carbocation, and loss of a proton from the neighboring carbon atom, which produce an alkene. So I hope this is clear to everyone. सबको क्लियर है मैकेनिज्म ऑफ डिहाइड्रेशन ऑफ अल्कोहल? क्लियर है? चल, गुड. सो on the similar basis, dehydration of ether also takes place, right? So intermolecular dehydration of alcohol gives ether also, right? So this reaction takes place at the lower temperature than for the dehydration of alkene. So basically we have a three reaction for the ethanol with the H2SO4. So when we treat ethanol with the H2SO4, we have a three reaction. I have to add one more. At 383 Kelvin, right? At 383 Kelvin. So at 383 Kelvin, diethyl sulfate will be formed. What form? Diethyl sulfate will be formed at 383 Kelvin. Similarly, at 413 Kelvin, ether will be formed, and 435 to we say 443 Kelvin, right? 443 Kelvin, alkene will be formed. So always remember these three reactions. Reaction of ethanol with the H2SO4. So if you treat ethanol at 383 Kelvin with H2SO4, then diethyl sulfate will be formed. Now, if we treat ethanol with H2SO4 at 413 Kelvin, 413 Kelvin, right? 413 Kelvin. Then what form? Ether will be formed. And if we treat ethanol with H2SO4 at 443 Kelvin, then definitely alkene is going to be, right? So this three reaction you must remember. What happened when the ethanol is treated with H2SO4 at these three different temperatures. I hope clear है सबको? Chalo. Now, the next thing is oxidation. So basically, alcohol can be oxidized to carbonyl compound, right? Alcohol can be oxidized to carbonyl compound. Here, carbonyl compound means what? Carbonyl compound means what, beta? That is, it may be aldehyde, right? It may be aldehyde, it may be ketone, or we say it may be carboxylic acid also. Okay? Carboxylic acid also. So here carbonyl compound means aldehyde, ketone and carboxylic acid. So we can easily convert alcohol into carbonyl compound like aldehyde, ketone and carboxylic acid. So primary alcohol give aldehyde or carboxylic acid on oxidation, right? How is this possible? Both aldehyde and carboxylic acid. How you get to know when they are giving aldehyde and when they are giving carboxylic acid? So if you just oxidize primary alcohol with the KMnO4 and K2Cr2O7, then it will give carboxylic acid. If you want to stop at the aldehyde level, if you want to prevent the further oxidation to become carboxylic acid, you have to add an reagent called PCC or PDC. This PCC and PDC act as a controlled oxidation and they stop the reaction at aldehyde level only and carboxylic acid will not form. So if you treat alcohol with oxidizing agent with the help of some PCC or PDC reagent, then aldehyde or ketone will be formed. If you want to use this PCC and PDC, then carboxylic acid, right? So similar, primary alcohol give aldehyde and secondary alcohol give ketone, right? And the tertiary alcohol do not usually undergo oxidation. Why tertiary alcohol do not undergo usually oxidation? Can anyone explain? Oxidation means what, beta? Oxidation means either they accept O, right? Or they lose H. This is a simple definition you learned from your 10th class, right? That is oxidation means removal of hydrogen or addition of oxygen. So if you talk about the tertiary alcohol, what is the structure of tertiary alcohol, beta? Yeah, for tertiary alcohol, we have a structure like this, right? So we observe that there is no hydrogen, right? There is no hydrogen. So no hydrogen is available for the removal, right? So how will you say that the oxidation will take place? So tertiary alcohol do not undergo oxidation. However, primary and secondary undergo oxidation. Primary give aldehyde, secondary give ketone upon controlled oxidation, right? So normally KMnO4, chromium trioxide, Na2Cr2O7, K2Cr2O7 are used as an oxidizing agent. Here we have an example. We have a propanol. So when we oxidize propanol with the help of K2Cr2O7 and H2SO4, will give propanol. And upon further oxidation, it will give propanoic acid. So basically, the aldehyde obtained by the oxidation of the primary alcohol get further oxidized to carboxylic acid as shown above. Right. And if you want to stop at the aldehyde level, you have to add an reagent called PCC and PDC. That is palladium chlorochromate and palladium dichlorochromate, right? This is PDC. So you have to add a reagent called PCC and PDC if you want to stop the reaction at aldehyde and ketone level. ठीक है? सबको समझ आ गया यहाँ तक? चलो. So now we are going to do some question related to this chapter, right? So the first question is, आइडोफॉर्म कैन बी प्रिपेयर फ्रॉम ऑल एक्सेप्ट, बताओ इसमें से कौन ऐसा है जिससे आइडोफॉर्म प्रिपेयर नहीं किया जा सकता है? सो आइडोफॉर्म कैन बी प्रिपेयर फ्रॉम ऑल एक्सेप्ट which of the following? So we all know that for the iodoform, yeah, someone, that is 3. Okay, someone say 3. Anyone? कोई कुछ और बोलना चाहता है क्या? चलो, एक बच्चे ने 3 बोला है. Let's see. Right, so basically what is iodoform test, right? So you study this thing in alcohol. Some more answers are coming. That is C again, right? Someone says C, that is 3 only. So we know that for iodoform test, what is the criteria? Iodoform tests are shown by only those aldehyde and ketone, right? Okay, only those aldehyde and ketone which show this particular type of linkage, right? So only those which having this particular kind of linkage show iodoform test, right? So let's see each one. So if I'm talking about isobutyl alcohol, ethyl methyl ketone, and isopropyl alcohol, and this is 3-methyl butanone. So many of you are saying that is isopropyl alcohol. Is this true? Isopropyl alcohol. Can any more? कोई और कुछ बताना चाहता है इसमें क्या? कोई भी और सजेशन? Yes, I'm giving 30 seconds. Any more? Only 2 बच्चों ने बोला अभी तक आइसोप्रोपाइल अल्कोहल. कोई और बोलना चाहता है? Yes. Yes. Isobutyl alcohol. Okay, good. So let me first draw the diagram of isopropyl and isobutyl. Then only you understand, right? Which one is true and which one is not true. So if I'm talking about the isopropyl alcohol having a structure like that is CH3, this is CH, and this is OH, right? Again, this is CH3. So this is known as isopropyl alcohol, right? This is isopropyl alcohol. On the similar basis, if you want to draw the structure of isobutyl alcohol, right? If you want to draw the structure of isobutyl alcohol, what is this isobutyl alcohol, beta? That is nothing but CH3. This is C. Again, we have CH3. This is CH2. And this is nothing but OH, right? 1, 2, 3. 1 H, we have 1 H here. So this is the structure of isobutyl alcohol. So what I am saying, iodoform tests are shown by only those which having this kind of linkage. So this having this kind of linkage, so this will show an iodoform test. So how will you say that option 3 is true? I am asking iodoform can be prepared from all except किससे prepare नहीं किया जा सकता out of these 3. So only isobutyl alcohol, that is option number A, right? That is isobutyl alcohol structure like CH3, CH, CH3, CH2, COH. So from this only you cannot prepare iodoform, right? So that's why the correct option is A. सबको समझ आया क्या? एक बार जल्दी बताओ. जिन्होंने ऑप्शन 3 बोला था उनको समझ आया क्यों गलत है? A is the correct answer, right? I'm talking about those who say option 3 is correct. उनको clear हुआ क्या? Why isopropyl alcohol is incorrect? Because in this question they are asking iodoform can be prepared from all except किससे prepare नहीं किया जा सकता, right? Yes, very good beta. Chalo. Now move to the next question. In the vector Mayer test, the color given by the primary, secondary, and tertiary alcohol are respectively. So you have to identify the color given by the primary, secondary, and tertiary. This is the another chemical distinguished test for the primary, secondary, and tertiary, just like the Lucas region. We already discussed about the Lucas region, right? What happened in the Lucas region, beta? Primary, secondary, and tertiary. So primary do not react, secondary react after 5 minutes, and tertiary react immediately. So just we have also one test called Victor Mayer test. So this test is based upon the color, right? So what color given by the primary, secondary, and tertiary? Yes, I'm waiting for your responses, beta. Fatafat, jaldi batao. Yeah, I get one. That is option 2. That is colorless. Okay, someone says, here I'm draw. This is primary, this is secondary, and this is tertiary. So someone says primary. Okay, that is colorless red and blue. What I'm getting from who said this? GNV, yeah. GNV Rajkot, GNV Bhavnagar, option 2 they are saying. That is colorless red and blue. Okay. Anyone else? Anyone? No? Beta, always remember this is very important. In the vector Mayer test, the primary alcohol give red color. The primary alcohol give red color. That give red color. Where the secondary alcohol give blue color. Blue. Blue color. And the tertiary alcohol give colorless. Right? This tertiary alcohol is colorless. So this is the correct one, right? So according to this, which option is correct? That is first. That is option number A. So first option, option number 1 is absolutely correct. Always remember in the vector Mayer test, the color given by the primary, secondary and tertiary alcohol are red, blue and C. Always remember like RBC. ठीक है ऐसे याद रखना RBC, रेड ब्लड सेल याद नहीं रखते थे जैसे वैसे याद रख लो RBC. So primary give red color, secondary give blue color, and tertiary give colorless, right? So this is the trick to remember Victor Mayer test, right? That is RBC. Clear है सबको? जल्दी बता दो फटाफट. Is it clear to everyone? Should we move to the next question? Done? Sure. Yeah, good. Now, the next question is very important, and we just discussed this topic, right? Few seconds ago only. So I hope all of you try this question and give correct answer. So the most suitable region for the conversion of this to this. So you want to convert alcohol to aldehyde. So which one is the most suitable region according to you? Yes, I'm waiting for reply. This question is from the oxidation part, right? This question is from the oxidation part. Okay, we get 4. JNV Chalang say PCC, JNV Nanded say 4. Okay, JNV Ahmedabad say 4. Okay, okay. Now the next is JNV Anand again say they are 4. Okay. Just remember this beta. This is very important question. And we already discussed this thing. Okay. Many of you are saying option 4th, right? Option 4. Only one student say that is only one GNV that say option 2 is the correct one. Yeah. We also have a one option like 2. Very good. Okay. So beta, I just told you whenever you oxidize alcohol, they convert into carboxylic acid. When you use the reagent called K2Cr2O7 or KMNO4 or we say CrO3, right? So out of these three, anyone you are using, they directly convert alcohol into carboxylic acid. But I told you one very notable point that if you want to stop the oxidation at aldehyde level only, then you have to add a reagent called PCC or PDC, because this PCC and PDC prevent further oxidation, or we can say that they act as a controlled oxidation. So they can stop the reaction from aldehyde level only. They stop the reaction at the aldehyde level only. So for this, the option 2 is correct, na? PCC. I already discussed this thing, right? Here only. That is, you need PCC and PDC if you want to stop the reaction at aldehyde level. So if you use K2Cr2 or KMNO4, then the reaction can convert from alcohol to carboxylic acid. You don't want this, right? You want only aldehyde to form, right? Sir, please repeat. Okay. I am saying that whenever you oxidize alcohol with the oxidizing agent like K2Cr2O7 or KMNO4 or CrO3, right? All these three, KMNO4, CrO3 and NO2Cr2O7 or K2Cr2O7. They convert alcohol into carboxylic acid. Right. Now, if we want to stop oxidation at aldehyde, because we know that alcohol to aldehyde, and from aldehyde to carboxylic acid. Now you want to stop the reaction at aldehyde level only. You want to stop the reaction at aldehyde level only, right? You want to stop the reaction at aldehyde level. So what you need to do? You have to add some reagent called PCC or PDC. These two reagents, palladium chlorochromate and palladium dichlorochromate, prevent the further oxidation of aldehyde to give carboxylic acid. And the alcohol converted into aldehyde level only and reaction stop. Right. So whenever you want to convert from alcohol to aldehyde, always use the reagent called PCC and PDC. Right. Because if you are using K2Cr2O7 and KMnO4, then reaction will convert it from alcohol to carboxylic acid only, not at aldehyde level. Right. Controlled oxidation won't take place. अब समझ आया सबको क्या बोला मैंने कि अगर तुमने पीसीसी और पीडीसी नहीं डाला तो अल्कोहल से सीधा कार्बोक्सिलिक एसिड बन जाएगा, वो एल्डिहाइड पे रुकेगा ही नहीं, ऑक्सीडेशन को ज्यादा करा देगा. तो अगर तुम रोकना चाहते हो एल्डिहाइड लेवल पे किसको, रिएक्शन को, सो ऑलवेज रिमेंबर वन थिंग बेटा, यू हैव टू ऐड पीसीसी और पीटीसी. यस सर, क्लियर, राइट, ओके. चलो, नाउ द नेक्स्ट क्वेश्चन इज, from amongst the following alcohol, the one that would react fastest with the concentrated HCl and anhydrous ZnCl2. Or we already discussed this topic also in yesterday class, right? This is the reaction of alcohol. This is the reaction of alcohol with the 5 different reagents. The first reagent is HCl and ZnCl2. The next is PCl5 and next is PCl3. And last and the most important, that is SOCl2, right? In all this case, we get RCl. So this one is also known as Lucas reagent, right? Lucas reagent. So I hope I give you a proper hint for this question. Yeah, I got one reply, that is of GNP Nalgonda, that is 2. Okay, okay, very good. Anyone? Any more one? कोई और बताना चाहेगा? कोई और ऑप्शन? And why option 2 is correct? Yes, why option 2 is correct? 2. JNV Bhavnagar also says that 2 is the correct option. Good. Why option 2 is correct? Can anyone explain? Because we know that. Yeah. We get yeah. Most of you are saying option 2, so it's very correct, right? So option 2 is absolutely correct answer for this, right? Yes, very good. Because this is tertiary alcohol, right? So very good, you are doing all very good. ठीक है, सबने बहुत अच्छा किया, सबने अच्छे इसको याद रिमेंबर कर रखा कि टर्सरी अल्कोहल का रिएक्टिविटी ज्यादा होता है. बिकॉज वी नो ना, इन लुकास रीजन टर्सरी अल्कोहल रिएक्ट इमीडिएटली, राइट? दे रिएक्ट इमीडिएटली. सो वेरी करेक्ट आंसर, राइट? Order of reactivity, very good beta, right? So the tertiary alcohol. So if you want to draw the structure of 2-methyl propanol, how will you draw this? 2-methyl 2-propanol. So we have a C, here we have a CH3, also we have a OH, and this is CH3. So this is known as a 2-methyl propanol, right? So this is a tertiary alcohol. So being tertiary alcohol, their reactivity is very high. So this reacts fasted with the concentrated HCl and anhydrous ZnCl. Very good. Now move to the next question. That is an unknown alcohol, right? An unknown alcohol is treated with the Lucas reagent to determine whether the alcohol is primary, secondary, or tertiary. Which alcohol reacts faster and by what mechanism? Right. So which alcohol reacts faster and by which mechanism, beta? Yes, someone says 2. Tertiary alcohol by SN1. Tertiary alcohol by SN1. Okay, anyone? Yeah, GNV Anand also says tertiary alcohol. Yeah, GNV Bhavnagar, 4th option. Okay. GNV Ahmedabad saying option 2 is correct. Okay. So most of you are saying option 2. Some says option 4. That is tertiary alcohol. So this is very much clear that is tertiary alcohol, right? The problem is here whether it is takes place by the SN1 or SN2, right? So how will you identify which reaction will be takes place through SN1 reaction and through SN2 reaction, right? So how will you know this? So we all know this. Why tertiary alcohol is more reactive? Can you give me the answer for this? Why tertiary alcohol? Why we take tertiary, secondary, and primary? That is tertiary alcohol is more reactive due to the formation of carbocation. Yeah, very good. Due to the formation of carbocation. So we all know that the tertiary carbocation, tertiary carbocation is more stable. We all know. And in SN1 and SN2, in which carbocation is formed? SN1 or SN2? In which? Yes, obviously, in SN1 reaction. Because what happened in the SN1 reaction now, basically we have a CH3, CH2 and Cl and KOH. Let us assume this KOH comes, this KCl will be removed, right? And this will form. So CH3, CH2 and OH. So this reaction will take place by the SN1 mechanism, right? SN1 mechanism, and in SN1, carbocation will be formed, right? So the rate of reaction depends only upon the alkyl halide or the nucleophile, only upon the alkyl halide. ठीक है? उस पे depend नहीं करता कि nucleophile strong है कि weak है. Only depends upon the alkyl halide. The order of reaction will be 1, and we know that SN1 reaction किसके थ्रू बनता है? कार्बोकेटाइन की स्टेबिलिटी के थ्रू. सो दैट्स व्हाई द करेक्ट ऑप्शन इज 2. समझ आया सबको? Why option 4th is not correct? Why SN2? Because in this carbocation is formed now, and carbocation only formed in case of SN1 reaction, not in SN2 reaction, right? In SN2 reaction we won't have a carbocation. जल्दी बता दो फटाफट. सबको समझ आया? क्लियर है ये? Yes, I'm waiting. किसी को समझ नहीं आया तो फिर से बता दो मैं. Okay, yes, got it. Good. Okay. The next question is, that is, phenyl magnesium bromide react with methanol to give what? So this is a phenyl magnesium bromide. So this we already discussed in previous class. What happened when the Grignard reagent react with the aldehyde, ketone and carboxylic acid? So this is the methanol, right? Okay, that is option 3. Okay, someone says option 3 is the correct one. Okay, good, good. Okay, Ahmedabad, JNB Ahmedabad say option 3 is correct. Okay. So in this question, they are asking phenyl magnesium bromide with methanol. Okay, 3. So can you draw the structure of phenyl magnesium bromide? Yes. So we have instead of CH3, we have this benzene. This is Mg. And this is Br. So this is, yeah, option 3. Okay, so this is the phenyl magnesium bromide. This react with methanol. This react with methanol, that is CH3OH. That is the reaction of methanol with phenyl magnesium bromide. Can anyone? I'm waiting for more responses. कोई और कुछ बोलना चाहता है क्या? Yes. Phenyl magnesium bromide. And write the reaction with methanol. Yes. Anyone? No? Chalo. So this is MgBr, this is CH3OH. What happened? What they form? Carbon ion attack. Okay, good. Okay. Anyone? No? Chalo. तो देखते हैं भाई क्या बनता है, मैं फाइनली ड्रॉ कर रहा हूँ कि क्या बनना चाहिए क्या नहीं. So whenever methanol, that is CH3OH, right? So we can also write this CH3OH now. How will you write CH3OH, beta? So we can write CH3OH like this having O and H. So this O negative and this having positive, right? On the similar basis, we know that this CH3 MgBr. So this is negative and this MgBr is positive. So what will form? So basically, when the phenyl magnesium bromide react with methanol, what form, beta? That is nothing but benzene plus MgOCH3Br, right? MgOCH3Br and benzene. So which option is correct? Now, can anyone say? अब कौन सा ऑप्शन करेक्ट है, मैंने लिख दिया है. Which option is correct, बेटा? अब तो मैंने रिएक्शन भी लिख दिया ना. That is it. The mixture of benzene and MgOMeBr, यानी ऑप्शन 2 इज करेक्ट. किसने 2 बोला था, देखो जरा. किसी ने 2 बोला था क्या? GNV. ओके 2. ओके ओके 3 ओके गुड. सो जिन्होंने भी 3 बोला था उनको क्लियर हो गया कि वाई 2 इज द करेक्ट आंसर. और जिन बच्चों ने 2 बोला था वो एब्सोल्युटली करेक्ट है, राइट. अ मिक्सचर ऑफ बेंजीन एंड MgOMeBr. सो ये बनता है व्हेन द बेंजीन, दैट इज व्हेन द फिनाइल मैग्नीशियम ब्रोमाइड इज ट्रीटेड विद मिथेनॉल. ओके क्लियर है, आगे बढ़े. चलो. So the next question is the best reagent to convert pent 3 2 all into pent 3 2 one is. So you want to convert pent 3 all into pent 3 2 all. So whenever such kind of questions are coming now, always try to identify the groups, right? Like तुम्हें कौन से ग्रुप से कौन से ग्रुप में जाना है. If you identify this thing, na, this task become easy for you. For example, in this, the best reason to convert pent 3 into all. So we have alcohol, and we want to convert this alcohol into one, that is ketone. So you want to convert alcohol into ketone. So which? Okay, JNB Ahmedabad, alcohol to ketone, very good. So what method you use, right? What method you use for the conversion of, or we say the best reason to convert this into this. Acidic permanganate, acidic dichromate, chromic anhydride in galicial acetic acid, or pyridium chlorochromate, right? So you have to select out of these only which option is correct and which is not. Yes. Anyone? I'm waiting. यस किसी का तो मैसेज आया है. कौन है? चलो. 4 JNV राजकोट से C एंड JNV आनंद से ऑप्शन 4. ओके चलो. और कोई? या फोर्थ ऑप्शन दैट इज पायरेडियम क्लोरोक्रोमेट. ओके चलो अभी देखते हैं which option is the correct for this. So we have, let me draw the structure first, right? JNB Ahmedabad says option 4. Okay, so let me draw the structure of pent 3 in 2 all. So this is the structure of here we have OH, right, and 2 on also. Someone says option 3. JNB Nanded says option 3. Okay, so this is the structure of pent 3 in 2 all, right? This is pent 3 in and 2 all. Now, if we want to convert this into pent 3 in 2 all, right? So you want to convert this into, yeah. ठीक है, इसमें कन्वर्ट करना है. So which reagent you are going to use, right? So if you are using acidic permanganate KMnO4 or acidic dichromate, so then what form beta? Then definitely they will form carboxylic acid. So these two options are not useful, right? This is not useful, this is not useful. Now the confusion between option 3 and option 4. Okay, out of three, these two options, which one is correct? The fourth option is palladium chlorochromate, that is PCC. So again, one important note here, that is we have a PCC, right? So always remember this, PCC, right? PCC is a better reagent for the oxidation of primary alcohol, where the chromic anhydride in galisate acetic acid may be used for the secondary alcohol. Right. So this is, we have a secondary alcohol. So PCC we are using if we have primary alcohol, right? So if we have a primary alcohol, then definitely we are going to use this PCC. Now in this, we have to convert PAN3 into all. We have a secondary alcohol. So out of these three now, that is chromic anhydride in glacial acetic acid, right? This is a better region to convert this. So we are using Cr2O3 in glacial. Glacial means beta CH3COOH, glacial acetic acid. Glacial acetic acid, right? So this one, that is option number 3, is absolutely correct. Always remember, if you have primary alcohol, then you use only PCC. Now in this question, you have to convert PAN3 into all into PAN3 to own. So for the conversion of secondary alcohol, the better agent is chromic anhydride in glacial acetic acid. समझ आया सबको? जल्दी बता दो एक बार. क्लियर है? सबको क्लियर है? यस सर, ओके बेटा. चलो. Okay, so next question is also very important question. So in this following sequence of the reaction, the compound D is. So you have to obtain compound D. Okay. Please repeat. Okay. क्या पूछना है बेटा इसमें? Okay. So देखो इसमें क्या था? Option A and option B, that is option 1 and 2, they are not correct. ये तो एकदम clear था, because permanganate and acid dichromate, they convert alcohol into carboxylic acid. तो इसको दो तो खत्म करो. Now we are left with the two options, that is option 3 and option 4. So out of these two only, the one is correct. So we know that PCC is used for the stop at the aldehyde and ketone level only. So we can think about PCC. But if we want to convert secondary alcohol into ketone now, then better reagent is chromic anhydride. Instead of this secondary alcohol, if we have primary alcohol, then we can use PCC. But here we have a secondary alcohol. And for the secondary alcohol, the better reagent for the conversion into ketone is chromic anhydride in galisate acetic acid. So just as simple as that. ठीक है? समझ आया? चलो. The next question is, in the following sequence of reaction, what is the compound D? So you have to identify the compound D in the following sequence of the reaction, right? So here we have CH3, CH2OH, and this react with P plus I2 and give A. Now this is treated with Mg and ether to form B. Now they further treated with the formaldehyde and followed by the hydrolysis. So what is the final product B? Can anyone explain me? Chalo. So we all know this thing now. This is P plus I2. So what they form? They form simply, that is CH3, that is CH2 and OH. So we know now ZnCl2 plus HCl, PCl5, we have PCl3, SOCl2 and P plus I2. They all convert alcohol into alkyl halide, right? They all convert alcohol into alkyl halide. So what you get? We get this, right? That is CH3, CH2 and I. And what happened when we treat alkyl halide with magnesium? That is the reaction of alkyl halide with metal in presence of ether, or we say dry ether. What will they form? They will form Grignard reagent, right? So they will form Grignard reagent like CH3, CH2 R MgX. That is Mg and this is I. So this is what form? MgI. क्लियर है. नाउ व्हाट द रिएक्शन ऑफ ग्रिगनाट रीजन विद द फॉर्मेल्डिहाइड, ये हम लोगों ने कल ही डिस्कस किया था. When you treat with the formaldehyde, we have a formaldehyde like H and H. What happened? This behave as a nucleophile. Hmm? This behave as a electrophile. Again, this oxygen is more electronegative. They want to shift the electron towards itself. So this carbon become partial positive, right? This carbon become partial positive. तो here इसके सपोर्ट में कौन आया? ये न्यूक्लियोफाइल आया. तो क्या बना? ये बन गया C. This is H. This is H. Okay, okay. Someone says propanol. Okay, let me see. So this is this one. और यहाँ पे क्या लग गया आके बेटा? यहाँ पे आके लग गया हम लोग का CH2 and this is nothing but CH3, right? And we also have like O, Mg and I. Now followed by the hydrolysis. So upon hydrolysis, what we get? We are left with the Mg, Br and I. And what we'll have? We have CH3, CH2, CH2 and OH, right? So this is what we have. This is called 1, 2, 3 propanol. So ये आंसर मिला है propanol. Very good. JNV राजकोट, very good. JNV नालगोंडा ने भी सही बताया, बिल्कुल very good, correct. That is propanol, right? So the D product what we have is nothing but propanol. That is CH3, CH2, CH2 and OH. So this is the product. Right? So if you are clear with the reaction mechanism, if you know which one is behave as a nucleophile, electrophile, what are the steps in this reaction, then you can easily, predict any of the chemical reaction very easily, right? Because we know that what happened when the alcohol is treated with P plus I2. We know that what happened after the alkyl halide is formed when treated with the magnesium, that is metal, then Grignard reagent will be formed. And we already discussed the reaction of Grignard reagent with the carbonyl compound. When you treat with the formaldehyde, we give primary alcohol. When you treat with the aldehyde, we give the secondary alcohol. And we treat with the ketone, then we'll get a tertiary alcohol, right? So this we already know. So I hope this is clear. सबको समझ आ गया? कोई बच्चा जिसको समझ नहीं आया हो जल्दी बताओ. या सबको क्लियर है? क्लियर है? आगे बढ़ सकते हैं? यस, क्लियर है ना? चलो. Now, let's quickly talk about phenols, and after that, we're going to solve numericals related to this chapter, phenol. So basically, the phenol, we all know that phenol having the hydroxy group, right? The hydroxy benzene is also known as the phenol, in which one hydroxyl group is attached to the benzene ring. So I'm going to quickly revise all this thing because I know you already studied this thing. So I'm going to quickly revise all this thing and trying to, try to solve questions, right? So this is beneficial for you all. So there is a basic nomenclature of phenol. So you must remember this common name also. For example, this is called orthocarisol because in ortho position we have a OH group. This is called metacarisol, right? This is called orthonitrophenol. This is similarly, if you have a 2 OH group, then this is called catechol, resveratrol, and the hydroquinone, right? If we have a one for benzadiol, then it is also known as a hydroquinone, right? Similarly, we have alpha naphthenol and 2,6-dibromophenol. So we have a 2,4,6-dibromophenol also. So these are some common names that you must remember, right? Okay. So our arene diazonium salt or the aromatic diazonium salt are obtained by the dissociation compound of primary aromatic amine as the given below, right? Because for the preparation of phenol, now we using BDC, that is benzene diazonium chloride. And how this BDC form? This BDC form when we treat aniline, that is NH2 benzene, right? Aniline with the NaNO2 and HCl at very low temperature, that is 273 to 278 Kelvin temperature. Then we have a formation of BDCl, that is N2Cl. N2Cl will be takes place, right? This N2Cl when react with water, that is a normal warm water, then phenol will be formed, right? So this is the first way for the preparation of phenol, right? From the BDC. So when you treat BDC with the warm water, then the phenol will be formed, right? So I hope this is clear. समझ आया सबको कैसे phenol बना पहले मेथड में? चलो. The next is the alkyl fusion of sodium benzene sulfonate. Right, that is the alkyl fusion of sodium benzene sulfonate. So this was the first commercial synthesis of phenol developed in the Germany in 1819. It can also be used as a laboratory method for the synthesis of phenol. Sodium benzene sulfonate is fused with the sodium hydroxide. Remember this? Sodium benzene sulfonate is fused with the sodium hydroxide to give sodium phenoxide, which on acidification give phenol. So here is the reaction. This is nothing but the sodium benzene sulfonate, right? This is the sodium benzene sulfonate, and when we react sodium benzene sulfonate with the NaOH, that is a sodium hydroxide, at the 623 Kelvin and a high pressure also. So at a high temperature and high pressure, right, we get sodium phenoxide, and upon hydrolysis, upon acidic hydrolysis, we get a phenol, right? So this is how we'll get the phenol. The next is DOS process. So this is also very, very, very important, right? This is called DOS process. So this process, chlorobenzene is heated with the aqueous sodium hydroxide under a drastic condition. Drastic condition means high temperature and a high pressure. Like temperature we have around 623 Kelvin, and the pressure is also around 300 ATM, right? So this is the process, Dawes process. So in Dawes process, basically we convert chlorobenzene into phenol. So for the conversion of chlorobenzene into phenol, the very good method that we use in industry's preparation of phenol is Dawes process, right? So here we have a chlorobenzene. When this chlorobenzene is treated with this NaOH in presence of this pressure and temperature as a catalyst, we'll get sodium phenoxide, which on the further acidic hydrolysis give phenol. So this method was in use for the many years, but now phenol is synthesized via cumene hydroxide, which is discussed below, right? So this method we had used earlier for in the industrial preparation, but now cumene we use the cumene for the preparation of phenol. So let's see how cumene give us phenol. So the reaction between benzene and propene in presence of phosphoric acid gives cumene. So how cumene will be formed? So let's first discuss how cumene will be formed. So when we react benzene with the propene, so this is what we have benzene, and this is we have propene. So when you treat benzene with the propene, right, then what they form? They form cumene. So the IUPAC naming of cumene is also known as 1-methyl-ethyl benzene, right? This is also known as 1-methyl-ethyl benzene. So this is the IUPAC naming of the benzene, right? This is not CH3. This is again CH3 only, because carbon having 1 bond, 2 bond, 3 and 4. So this is cumene, okay? Now, when the cumene is oxidized, when the cumene then oxidized to give cumene hydroperoxide. So this O2, so this O and O will form. So this cumene hydroperoxide will be formed. In the final step, cumene hydroperoxide is treated with 10% sulfuric acid to give phenol and acetone on hydrolytic rearrangement. So this cumene peroxide, when treated with the 10% of H2SO4, then only phenol and acetone will be formed. So note this, propanol is obtained as a valuable byproduct in this reaction. That's why this method is preferable method for the preparation of phenol, because with phenol we also get acetone, right? So this is how will you get this. So propanol is obtained as a valuable byproduct in this reaction. Okay? Okay. So this is the final step in this reaction for the preparation of phenol. Okay. Now, what are the physical properties of alcohol phenol? So basically, we all know the physical properties of alcohol due to the presence of hydrogen bonding. They show high boiling point, more solubility. So just like this, phenol also shows some physical properties. So compounds similar to alcohol phenol also have the hydrogen atom linked to the electronegative oxygen atom. Thus, we can say that phenol also exhibit hydrogen bonding and hence have the higher boiling point as compared to that of the hydrocarbon of the similar weight. If I'm talking about the phenol having boiling point, they having boiling point 454.7 Kelvin, and on the same basis, if I'm talking about the boiling point of methyl benzene, almost they're having the similar molecular weight, right? So the boiling point difference is very much. If I'm talking about phenol, they having the boiling point of 453.7 Kelvin, where in case of toluene, that is methyl benzene, the boiling point is only 383.6 Kelvin, right? So this play a very crucial role, right? Due to formation of hydrogen bonding only. Now, let's see the more important reaction of the phenol. Phenol are much more acidic than alcohol. This point you must remember. That is, phenol are much more acidic than alcohol. If I'm talking about the pKa value of some phenol, so we can, we have one table with us, like phenol having the pKa value 9.89, right? And similarly, 2-methyl phenol having pKa value 10.28. So we know that higher the value of pKa, lower the value of Ka and lower will be in the acidity. Because for the acidity, Ka value will be more. And pK and Ka are inversely related to each other. है ना? ये सबको clear है? यानी अगर किसी का pKa का वैल्यू ज्यादा है, इसका मतलब क्या हुआ? वो acidic कम है. So for example, 2-methyl phenol, they having more pKa, means less acidic. 2-chlorophenol, we have a 2-chlorophenol, we have a 2-nitrophenol, 3-nitrophenol, 4-nitrophenol, and 2,4,6-trinitrophenol. So we can say that picric acid is a very, very, very good acid. We can see now here pK value is very less, only 0.38. It means they are having a very low value of pKa. What does it mean? It means they have a higher acidic value, higher acidic character, right? So we can observe that if we put electron withdrawing group like halogen, like NO2, right? These all are called electron withdrawing group. So if we put electron withdrawing group on phenol, their acidic character will increase, right? Now, if we put electron donating group like CH3, like OCH3, right? These all, what they do? They decrease the acidic value, right? So always remember that whenever electron withdrawing group is increases on phenol, their acidic value also increases. Whenever electron donating group is induced in the phenol ring, then their acidic character decreases, right? So since the phenol are acidic in nature, they are soluble in dilute sodium hydroxide, because we know that when the phenol being acidic in nature, they react with the base to form sodium phenoxide and hydronium ion. Okay, now the greater acidity of phenol can be attributed to the resonance stabilization of the phenoxide. More the stable phenoxide, more will be in the acidic nature. So the resonating, देखो होता क्या है रेजोनेटिंग, मतलब रेजोनेटिंग स्ट्रक्चर से कैसे पता लगेगा तुम्हें, क्या स्टेबिलिटी, क्या फर्क पड़ता है? स्टेबिलिटी ये है बेटा कि जैसे फिनॉल के ऊपर क्या है, वी ऑल नो दैट फिनॉल के ऊपर OH है, तो फिनॉल जो है वो O और H से बंधा हुआ है. अब हम सबको पता है कि जितना जल्दी ये H टूट के निकलेगा, अंडरस्टैंड, जितना जल्दी ये H टूट के निकलेगा, वही तो एसिड है. एसिड का मतलब क्या है? H प्लस देना. तो अब ये H प्लस टूट के निकल गया तो O पे नेगेटिव चार्ज आ गया, क्योंकि H ने अपना इलेक्ट्रॉन दिया, प्रोटॉन बनते वो निकल गया, तो O पे आ गया नेगेटिव चार्ज. सो इफ दिस नेगेटिव चार्ज आर well stabilized by this phenoxide ion, then only they are stable. भाई जितना ज्यादा स्टेबल होगा, मान लो H प्लस निकलने के बाद खुद ही स्टेबल नहीं रहता, तो ये H प्लस क्यों देता? ठीक है, तो ये H प्लस देने के पास इस पे नेगेटिव चार्ज आया, एंड दिस नेगेटिव चार्ज आर इजिली स्टेबलाइज्ड बाय द रेजोनेंस. दैट्स व्हाई फिनॉल आर मोर एसिडिक, बिकॉज ये ज्यादा स्टेबल H प्लस दे रहा है, और H प्लस देने को ही एसिडिक बोलते हैं, और H प्लस देने के बाद भी ये बहुत ज्यादा स्टेबल है, क्योंकि ये जो नेगेटिव चार्ज है उसका स्टेबलाइजर हो रहा है, डीलोकलाइजेशन हो जा रहा है ड्यू टू रेजोनेंस. दैट्स व्हाई फिनॉल आर मोर एसिडिक इन नेचर. समझ आया सबको? Why the delocalization of negative charge over the benzene ring stabilize the phenoxide ion? And no such stabilization is possible in case of alcohol. That is in case of alkoxide ion. That's why if I'm talking about alcohol and phenol, phenol is more acidic than alcohol. Everyone, किसी को कोई डाउट यहाँ तक पूछ लो जल्दी फटाफट. किसी को कोई भी डाउट हो पूछो फटाफट यहाँ तक. Is it clear to everyone, right? Or anyone having any doubt, you can ask. No doubt? Chalo, very good. So this is all about the greater stability, greater acidity of phenol due to their resonance stabilization. Right? Good. So we already discussed all these things. So I hope time is already, okay, time already ho gaya hai. So in the next class also we are going to discuss this phenol, right? in one class also, one class we all also we required, in which we are going to discuss the electrophilic substitution reaction and questions based only on the chemical properties of phenol and ether, right? So in the next Saturday and Sunday that we are also going to do this phenol chapter as well, and in this we are going to do some questions basically related to phenol only, because alcohol वाला part already हम लोगों ने कर लिया है. Explain the stability of the phenol. Okay बेटा, let me explain once. I'm talking about stability of phenol. Why phenol are more stable, right? Because as soon as H plus is removed, right, then H plus removed, then oxygen become negative, right? In oxygen, they having the negative charge. So how this negative charge are stabilized, this will give their stability, right? So because of this resonance, this negative charge are stabilized. Delocalization of electron will be takes place. Here you can show in this resonance diagram. This negative charges goes to this oxygen atom, right, the double bond. Then they shift to this ortho, para, and ortho position. So this negative charge is stabilized at all ortho, para position, and due to this only, this phenol is more stable, right? Because acidic means what? Acidic वही अच्छा है जो H plus को दे दे. अब जब वो H plus को दिया, then O become negative. So how this negative charge are stabilized by this ring, na? Then it will show their stability. And why this negative charge is stabilized? Due to resonance. Because resonance is what? Delocalization of electron. वो इलेक्ट्रॉन घूमते रहते हैं चारों बगल resonance के चलते. That's why they are much more stable. समझ आया? Why they are much more stable? चलो है ना. So तुम लोग इसको करो, take care, right? In the next class we are going to start from this electrophilic substitution only and try to solve some question related to phenol and their chemical properties. Also we are going to cover ether part as well, right? So till take care और इसको आराम से revise करो and try to solve more and more numericals, not numericals technically, try to solve more and more previous year questions related to this alcohol phenol, right? Okay.